Ionic bonding is the connection of two oppositely charged ions. Ionic bonds consist of one nonmetal ion and one metal ion. An example of ionic bonding is found in sodium chloride or table salt. The sodium atom has one valence electron that it is willing to give up, whereas the chlorine atom wants to obtain one valence electron. This would make both of the atom's valence shells full. So sodium gives up one of its valence electrons and chlorine receives it. This makes both of the atoms obtain complete valence shells, while also turning the sodium ion positive because there are more protons than electrons, and making the chlorine ion negative because it has more electrons than protons. Because of this change in charge, sodium becomes a cation or positive ion, and chlorine becomes an anion or a negative ion. These two ions link and create salt molecules. Covalent bonding is the sharing of electrons between nonmetal atoms. This sharing of electrons creates bonding pairs, which helps to stabilize an atom. There are three kinds of covalent bonds: single bonds, double bonds, and triple bonds. Single bonds are formed when two electrons from separate atoms form a pair together. An example of this is shown with water molecules. Double bonds form when two pairs of shared electrons conjoin together. Carbon dioxide has two double bonds connecting the oxygens to the carbon. Triple bonds form when three shared pairs connect, and this is shown in nitrogen gas. In electron dot diagrams, single bonds are shown with one connecting line, double bonds with two, and triple bonds with three. Metallic bonding is the collection of tightly packed metal ions. Positive metal ions are pushed together, while their electrons are very free. Electrons hop from one ion to another and are not associated with any particular atom. The actions of these free-flowing valence electrons are what gives metals most of its properties. Metals' high electrical conductivity, malleability, ductility, and structure are mostly determined by the erratic valence of electrons. Valence electrons are the most important aspect of chemical bonding. Because all atoms have valence electrons, they interact with each other in different ways. In ionic bonding, valence electrons are transferred from one atom to another. This creates two ions of opposite charge, so they attract each other, similar to the way magnets function. In covalent bonds, valence electrons are shared in pairs to fill atoms' outer shells. The sharing of these electrons can take three forms depending on how many valence electrons must be shared to fill the outer shell. In metallic bonds, valence electrons roam freely, moving in and out of atoms. The decentralized valence electrons give metals most of their properties. Periodic trends affects bonding by showing how evenly atoms share electrons through ionization energy and electronegativities. Covalent bonds with different electronegativities are polar, whereas closer electronegativities are nonpolar. A polar bond has unequally distributed electrons and usually results in a bent molecule structure. The metals on the periodic table lose electrons, and the nonmetals gain electrons because of ionization energy. Overall, periodic trends affects almost every aspect of chemical bonding.